Hello everyone and welcome back. Today we're going to be talking about two different types of rates of change. So we're going to talk about AROC and IROC.
AROC is average rate of change.
Good. Okay, that was Josh introducing AROC. So average rate of change. Hopefully when you hear the word rate of change, it makes you think of slope. Okay, and so if we talk about doing the rate of change of a linear function, we use just slope between the 2 points. But when we're talking about any other function besides a linear function, we know that rate of change is not a constant thing. And so when we want to find the rate of change over an interval, we're looking at what the slope is between the endpoints of those in that interval. So it's the slope of the secant line. Okay, so if we take a look at this graphically with our graph here of f of x, if I have an interval of which I'm looking for the rate of change, you can tell clearly that this is not a linear function, that f of x is some sort of polynomial function. And if I were to find the rate of change, well, I have to be given a specific interval because as we said, we don't have a constant rate of change. So if I were to look, for example, and the interval was between here, which we'll call this as our first x value, and here, okay? Well, what's happening graphically between those two x values? Well, you can see what's happening is the graph is going downhill. And so the average rate of change between here and here would be negative. We'd be going downhill, it would be negative, and you can see that the slope is pretty shallow, so something negative, maybe a small decimal. Then if I were to change and instead switch my interval to between here and here, well, now what's happening there on the graph is we definitely see that we are going increasing and it's pretty steep. So the average rate of change here would be positive and it would be much steeper. Likewise, I could look over the entire interval from the very first place I put an x value all the way to here, okay? And now what's happening? Well, now you're going down and you're going up. And so the average rate of change for this, well, the negative and then positive, but which one kind of supersedes the other? And so what's the average rate of change between these two x values overall? So the concept here is if I were to take any two x values, okay, and we're going to call them A and B. So if I say A here and B here. All right, so we have an interval between two given x values, A and B, on our graph. All right, so the slope, the average rate of change is the slope between those endpoints. So if I were to take those x values up onto the graph, you can see that this is going to intersect right there. And this B is going to intersect the graph right there. So what is the slope of the line that connects those two, that passes through those two endpoints? That line is called the secant line because it intersects the graph in two different places. And so what are the y values? What are the outputs for these given x's? Well, if this graph is f of x, and for this given A input, then this output would be f of A. And here, this output would be f of B. So let's think about how we find the slope of a line. The slope of a line is the change in y over the change in x. So if I'm talking about the average rate of change, I said it's the slope of the secant line, which is the change in y. Well, what are my y values here? They're f of B and f of A. So it's f of B minus f of A over the change in x's. And what are my x's? B minus A. And so this is the formula for average rate of change over the interval A comma B for the function f of x. The second kind of rate of change that we're going to talk about is IROC. That's instantaneous rate of change. That's the rate of change at any given moment, at any instant. It's a derivative at a point. It's the slope of the tangent line. Okay, so now if I'm taking a look at this graph again, and I want to find the slope at a given instant, so a given x value. So now if I want to find the slope here at this x value right here, A. Well, now, again, that A has an output, okay, right here, and this would be f of A. So if I want to find the slope at that exact moment, well, that's the slope of the tangent line. That is the slope of the line that intersects the graph just at that one point. Okay, so something like that. And that slope we call f prime of A. So that's our derivative at A. That's what we've been talking about up to this point. So IROC is actually nothing new. It's the instantaneous rate of change. It's the same as the slope of the tangent line. It's the same as the derivative at that point. Okay, so we're going to go ahead and do a couple problems here. We're asked to find the average rate of change and the instantaneous rate of change for a given function over an interval or at a certain point. And so for this first one, we're asked to find the average rate of change on the interval 1, 4. So, all right, we're going to go ahead and grab our formula for average rate of change. Is f of b minus f of a over b minus a. I remember it's just the slope formula. And so here, our interval is our a comma b. And so what we're doing is we are literally just plugging in our a and our b, our interval endpoints, in for the formula. So it's just f of 4 minus f of 1 over 4 minus 1. Okay, well, f of 4 means I'm plugging 4 into this function. So that would be 3 times 16 minus 5 times 4. Minus f of 1 would be 3 times 1 minus 5 times 1 would just be 5 over 3. So let's clean this up. 3 times 16 is 48 minus 20 would be 28 minus 3 minus 5 is negative 2 over 3. So that becomes 30 over 3, which is 10. So my average rate of change here is 10. The average slope over that interval is 10. Okay, the second part wants us to find the IROC, the instantaneous rate of change at x equals 2. So that means that we're going to actually do the derivative of the function at 2. Like I said, what we've been doing all along. So we first need to find f prime of x. And so that's just going to be 6x minus 5. And then f prime of 2 is 6 times 2 minus 5. So 12 minus 5 would be 7. So the instantaneous rate of change, the actual slope at 2, is 7. Okay, in the second example, we're given a new function, this time f of x equals cos half x. We're asked to find the average rate of change over the interval pi over 2 to pi. All right, so I'm going to jump right into it and find my average rate of change. That would be, again, this is your interval, so this is your a and this is your b. So it'd be f of pi minus f of pi over 2 all over pi minus pi over 2. All right, so when I plug pi in, I would get cosine of half pi would be pi over 2, that's how we usually write it, minus cosine of half of pi over 2 would be pi over 4. All over, well, this is 1 pi minus a half a pi is half pi. All right, so cosine of pi over 2. All right, hopefully when you see cosine of pi over 2, you think about your cosine graph. And if I think about my cosine graph, it looks like this, okay? And so I know that this would be pi here. Pi over 2 is right here. And so cosine of pi over 2 is, in fact, 0. So I get 0 minus, all right, cosine of pi over 4. Now, hopefully your mind goes to the unit circle. Okay, so if we're thinking about the unit circle, pi over 4 is right here. It splits between 0 and pi over 2. And the coordinates of that point are root 2 over 2, root 2 over 2. Again, should have memorized. And so cosine is the x coordinate there, which then would be root 2 over 2 over pi over 2. And so our average rate of change here is negative root 2 over 2 over pi over 2. Well, hopefully you're looking at that and saying, oh, I can clean that up. Just multiply the top and bottom by 2. And so we end up with negative radical 2 over pi. So our average rate of change here is negative, okay, and that is the answer. Okay, the second part of this asks me to find the instantaneous rate of change at pi over 3. Okay, so I'm just going to rewrite my function. It was f of x is equal to cosine of half x. All right, so instantaneous rate of change, remember, is just the derivative of that function at that intended x value, which the x value here was pi over 3. All right, so f prime of x, I'm going to take the derivative of the function, would be negative sine, keep the angle, half x, times the derivative of the angle would be half. So f prime of x here would be negative 1/2 sine of half x. All right, last step would be to go ahead and plug in your x value of pi over 3. So we get negative 1/2 sine half of pi over 3 would be pi over 6. Okay, again, pi over 6, you should recognize that as one of your angles on the unit circle. Okay, the pi over 6 angle looks right about there. And that point on the unit circle, again, we should have memorized, is root 3 over 2, comma 1/2. So this time if I'm evaluating sine is the y coordinate of a point on the unit circle, so that would be the 1/2. All right, so it's going to be negative 1/2 times sine of pi over 6 is 1/2. And so we end up with the instantaneous rate of change as negative 1/4. The next several problems that we're going to take a look at are average rate of change problems, and where we would find those on the exam would be really like as a part A of several parts of an open-ended or free response part of the exam. And so these are, usually like quick little 2-point questions, definitely something we want to get right, and so we want to make sure that we practice them and know what we're doing. So this first example says the number of people waiting in line at the movie theater to see the premiere showing of a new Star Wars movie is modeled by a continuous function L of t from 0 to 60 minutes. Values of L of t, the number of people in line at various times, are shown in the table. Okay, so it's asking here for the average rate of change. So they're not going to use AROC. They're going to say average rate of change of the function over the interval 0 to 60. So this is our 0, 60. This is our interval that they're giving us. Indicate the units of measure. Okay, so any way that we're doing this, now before we did it from a function, from an equation, now we're doing it from the table. Same idea. Average rate of change is equal to, in this case, L is our function, so we'd say L of 60 minus L of 0 over 60 minus 0, because that was our A and our B of our interval. All right, so then we just take the information from the table. So L of 60 is 26 minus L of 0 is 7 over 60 minus 0 is just 60. So 26 minus 7 is 19 over 60. So there's our slope. Now, the second part of this oftentimes tells you, indicates units of measure. So on the AP, getting the answer 19 over 60 is part of your answer, but indicating the correct unit of measure is the other part. Remember, rate of change is our slope. Okay, so when we talk about rate of change, we need what is changing over what unit of measure. So in this case, the two things that are being compared are people and minutes. So 19 over 60 is a positive slope, and you can see that the rate of change, the slope of the line, the number of people in line is increasing, okay, over a period of time. And so our units of measure here would be people over minutes. So 19 over 60 is a positive slope, people per minute. So this tells us that every minute the line is increasing by approximately, 19 over 60 is approximately a third of a person. So every minute it's increasing by a third of a person. Or the way that we would really think about that is every 3 minutes another person gets in line, approximately. All right, let's take a look at the next one. Okay, as we look at this next one, this question is talking about traffic flow being flowing through an intersection, and this function is measuring the number of cars per minute. And then they're asking you here for the average rate of change of the traffic over the time interval. So be careful to read that interval, 10 to 15. They do not want the entire interval the whole time that this is measured. They only want from between 10 and 15 minutes. So that is our A comma B, okay, 10 comma 15. So we're going to go ahead and just pull out our average rate of change formula is equal to F of 15 minus, I guess it should be capital F, F of 10 all over 15 minus 10. Okay, so you're going to go ahead and plug that 15 and the 10 in the given function. So it would be 82 plus 4 sine of 15 halves would be 7.5. Okay, minus 82 plus 4 sine of 10 halves is 5. All over 15 minus 10 is 5. Okay, I'm hoping that you notice this is an exciting question because we are allowed to use our calculator. So this would be on the open-ended part where calculators are allowed. And whenever we're entering in a big fraction like this, I want us to get used to using a function that I'm not sure if you've used before in your calculator. So if you hit the alpha button on your calculator and then go ahead and hit the y equals, what comes up is this menu here. And it's a whole bunch of different fraction options. What we're going to use is choice 1. So you just go ahead and hit enter. And then what that gives us, what hopefully that will give you on your calculator, is a numerator and denominator it gives you a fraction bar, okay? So what you're going to be able to do is enter the numerator in the top and the denominator in the bottom. It alleviates our need for parentheses around binomials in the numerator and denominator. It's very helpful, and make sure that we get the right answer. If your calculator, when you press those buttons, you don't see this screen right here, okay, that means your calculator hasn't been updated. Bring it into me and I will update it for you. Okay, so when you enter it in, it's going to look something like this screen down here. All right. Obviously, you're only seeing a portion of it. So make sure that you do put the parentheses around each of the terms here. Okay, when we do that, the calculator is going to give us back a very long decimal for an answer. Now, standard rules for the AP exam is always round to 3 places, so that's what we're going to practice all year long. So they will almost never tell you what to round to. You're always just going to round 3 places. So it's 0.03469, blah, blah, blah. So we're going to go ahead and round that. It would be 0.035. And then, of course, we need our units of measure. So what is this measuring? It's measuring cars per minute. Okay, this is a positive slope, and so it communicates to us that we have an increase of 0.03435 cars every minute. Okay, this next problem, we're given another table of values, and we're told that that they're taking a metal wire and heating it at one end, and the table gives temperatures in degrees Celsius of the wire X centimeters from the heated end. And we can say it tells us that the function is decreasing and differentiable. So estimate t prime of 7. Okay, so t prime of 7 is asking for the derivative of the function at an x value of 7. Well, clearly I don't have an equation for t of x, so I can't calculate the exact derivative of t of x. But what I can do is use the concept of t prime of 7 is really asking for the slope of the tangent line at 7. Well, obviously, again, I can't find that exact slope, but I can estimate it. How? I can use average rate of change using x values surrounding the 7. So where would 7 fall in our table? It would fall right here. So if I want to use the average rate of change, okay, what is the function changing on average between over the interval x equals 6 and 8? That is going to give me an estimate of the slope at 7. All right, so I'm going to go ahead and do the average rate of change formula, okay, using my interval of 6 to 8. So it would be t of 8 minus t of 6 over 8 minus 6. All right, t of 8 here is 55. T of 6 is 62 over 2. So that gives us an answer of negative 7 halves. So my slope is negative, which is good because we were told here that the function is decreasing. So I'm going down -7/2. What's going down? The temperature, so degrees Celsius per what? Per centimeter. So every centimeter I move away from the heated end, my temperature is going down -7/2, -3.5. Now, I only evaluated it over the interval 6 to 8, and so that's the slope in that interval, and so that's my average rate of change, my approximate slope for the function at 7. Okay, the last one we're going to do today is giving us a continuous function, and it says it's defined on the closed interval from -4 to 6. It says for how many values of a, where a has to be between -4 and 6, is the average rate of change of f on the interval from a to 6 equal to 0? Give a reason for your answer. Okay, so let's just take apart what we know. We know that we have a formula for average rate of change, and they give us an interval. So let's start there, okay? Average rate of change is equal to f of 6 minus f of a over 6 minus a. Now what they want is for the average rate of change to equal 0. So f of 6 minus f of a is equal to 6 minus a. Or I'm sorry, all over 6 minus a. So when is this going to happen? Well, what do we know about fractions? Hopefully our gut is telling us we know that if this numerator is equal to 0, then in fact the whole fraction is equal to 0. All right, so we need f of 6 minus f of a to equal 0. Well, when will that happen? That happens when f of 6 is equal to f of a. All right, so let's look at our graph. What is f of 6? F of 6 is 1, right? Here's your 6 value. F of 6 is 1. So it's saying where else on the graph will, when you put an input in, will you get back an output of 1? Well, in order to evaluate that, I'm really asking for this line, y equals 1. How many places on this line does the graph f intersect? In other words, how many places is that graph at a height of 1? Well, I can see one place right here, and I can see one place right here. And so you don't need to know the exact values of those a values. You just need to know that there are 2 values for a. And that is your answer, and really your justification and your explanation is here, and especially if you graph in that line y equals 1 and show those points of intersection, that's showing there's 2 other places where that would happen. Okay, so that's the end of this lesson on average rate of change. I will see you in class next time, and we'll be practicing more of these there. Have a great night.